Wet age-related macular degeneration, AMD, is a leading cause of blindness and is typically treated with regular injections of medication into the eyeball. Scientists at the University of Illinois Chicago have developed a new compound that inhibits the activity of a protein known as N-binding 3, EB3, which is present in the endothelial cells that line the inside of blood vessels. In tests performed on mice and monkeys with wet AMD, twice-daily doses of the EB3 inhibitor stopped the problematic blood vessels from leaking, significantly reducing damage to the macula within 2 to 3 weeks. The EB3 inhibitor also reportedly reversed aging-related eye problems, in which changes in gene expression led to inflammation and hypoxia, lack of oxygen. The medication restored gene expression to what is described as a normal, healthy state. Scientists are now looking into the possibility of using special contact lenses to automatically release the EB3 inhibitor into the eyes over time. Plus, they're investigating the medication's potential use in the treatment of non-eye-related maladies, such as stroke and heart disease. Scientists at the University of Birmingham have also developed macular degeneration treating eye drops of their own. These eye drops utilize a cell-penetrating peptide to carry existing drugs to the relevant part of the eye within minutes.
Dry rock
Sage
formations.
Geosystems has developed
The
a new
first,
form of
called
cheap
heat
energy
root,
storage called
is used to
Earthstore
create
that
artificial
uses the
reservoirs
earth as
in
a
hot
giant
dry rock
bellows,
and
pumping water
affordably
into
convert this
underground
heat to
fractures,
electricity.
then letting it
And
squirt
in
back
2022,
up at 70%
we field tested it for the first time.
200%
We
efficiency.
re-entered an
If you
abandoned
also
gas
harvest
exploration
heat
well
energy,
in Starr
the
County,
system is
Texas.
adapted from a
We then
similar
performed a
technique
series of
that's used
circulation
in oil
tests.
production,
We
where
pumped down
fluid
the
is
annulus
injected
of the
into a
tubing
shale
encasing
oil deposit
into the top of the
and
fracture,
left there to heat
down
the
the
oil,
fracture,
reducing
and out
its
of the well
viscosity
up the tubing.
and making it easier
Finally,
to pump out.
we performed
Sage,
a series
however,
of pump-in
uses dense
tests
drilling
to
mud
fully fill
forced
the
at
fracture
high
with
pressure
fluid.
into rock-deep
We pumped
underground
fluid
at
into the
disused
fracture,
oil wells
shut it
to
in
push
for a
slim
specified period
fractures
of time,
apart,
and then flowed the
pumps
fluid
water
back.
in, again at high
These
pressure,
tests produced
to
very
keep the
successful
fractures
results
inflated.
and
When
point to a
it's time
huge
to recover
opportunity
the
in the
energy,
geothermal
it's as
space.
simple as opening the
Our
valve.
second
The pressure
technology
from the
applies
earth
heat
all
root
around the
into
fracture
Sage's heat
squeezes it
cycle
back
well
together,
design.
and
We
the
estimate
water
that
is
we can
forced
deliver
back
a
up the
50
pipes,
megawatt power
where it can
plant
be
by
run
drilling
through a
an
turbine
18
to
to 20
harvest
well pad
electricity. As a
using
pressure battery
multi-well pad
alone,
drilling
this
techniques
solution
commonly
is
used
quite
in the
efficient,
oil and gas
with a
industry.
round-trip efficiency
The
of
short
70
distance
to
between wells
75%.
increases
The
efficiency
Earthstore
by
system
enabling
packs
the
water in
movement
with
of the
hot
drilling
rock
rig
with
between
lots of
wells
surface
without
contact
being
and
disassembled,
locks it down
also
there.
referred
So
to as
when
a
it's
walking
released,
drilling rig.
not only does the heat increase
This
the
results
pressure
in a
with
small
which
surface
the water
footprint,
rushes back
huge
up,
efficiencies,
driving the
and
turbine
supply
harder.
chain
There's
advantages
also
not
the
realized
opportunity
in
to
a
harvest
one-off
that
single
heat
well.
by running it through a heat
Geothermal
exchanger,
energy
such
generated
that
from
you
this
end up
pad
getting
will
more
be like a
energy out of your
multi-cylinder
Earth
engine,
battery than you put
meaning
in. The Droneliner is a crew-less aircraft that is being developed to reduce the cost of air freight by over 70%. It has a rectangular body that is optimized for carrying intermodal shipping containers. It is powered by turbofan engines that can use SAF, sustainable aviation fuel, biofuel or hydrogen. The Droneliner will come in 2 versions, the single-engine DL200 and the twin-engine DL350. The DL200 will be able to carry 36 to 40 containers on 2 levels, with a maximum cargo weight of 200 tons. The DL350 will be able to carry 70 to 80 containers on 3 levels, with a maximum cargo weight of 350 tons. Both models will have a range of 6,500 nautical miles, 12,038 kilometers. The Droneliner is crew-less, which reduces costs and allows for a more cargo-friendly body shape. The Droneliner is optimized for carrying intermodal shipping containers, which makes it more efficient and cost-effective. The Droneliner can use SAF, sustainable aviation fuel, biofuel or hydrogen, which reduces its environmental impact. Scientists have discovered a biochemical mechanism linking attention deficit hyperactivity disorder, ADHD, and autism spectrum disorder, ASD, with the common but problematic compound bisphenol A, BPA. This is the first study to describe a biochemical mechanism linking BPA exposure to ADHD and ASD. The study found that children with neurodevelopmental disorders have a much harder time eliminating BPA from the body. BPA is a common chemical found in many everyday products, including food packaging and containers. BPA is an endocrine disruptor that can interfere with the body's natural hormones. The study's findings suggest that BPA exposure may be a contributing factor in the development of ADHD and ASD. Stanford scientists have received a U.S. federal contract worth US $26.3 million to bioprint functional human hearts and implant them into live pigs. The goal is to create a new way to produce organs on demand, without the need for donated organs or the risk of rejection. The team plans to use an automated bank of bioreactors to grow all the cell types needed to produce a human heart, including ventricular and atrial cardiomyocytes, nodal cells, cells that form the Purkinje fibers, smooth muscle cells, immune cells called macrophages, and endothelial cells. These cell cocktails could then be fed into a bioprinter to act as the ink to 3D print fully functioning human hearts. This is a major step towards the goal of bioprinting organs on demand. The team plans to use an automated bank of bioreactors to grow the necessary cells, which will make it possible to produce hearts in large quantities. The team plans to test the hearts in the lab, and eventually in live pigs, which is necessary to prove that this technology is viable. BAE Systems Molloy Aeronautics T-600 Heavy Lift Uncrewed Air System was launched an inert Stingray training torpedo. The T-600 is an electric-powered demonstrator craft that is easily broken down for transport, has a payload of 200 kilograms, 441 pounds, top speed of 140 kilometers per hour, 87 miles per hour, and a range of 80 kilometers, 50 miles. This was the first time such a weapon had been deployed by a modern drone platform as part of a sea mission. The purpose was not only to show off the T-600's anti-submarine warfare capabilities, but also its potential for automated logistics, resupply, casualty evacuation and other tasks. BAE Systems will use the T-600 as the basis for an all-new T-650 all-electric heavy lift UAS, with rapid reconfiguration capabilities for military, commercial and humanitarian markets. The Lawk 1 Arkansas glasses are a lightweight, 80 grams, and splash-resistant pair of glasses that project information onto both lenses. The glasses can display real-time information such as current speed, distance traveled, elapsed time, and calories burned, as well as turn-by-turn navigational cues, incoming text messages, and heart rate and pedaling cadence. The Lawk ones also have built-in speakers for music playback, a microphone for voice commands, and a 120-degree lens camera for shooting 4K video and 8MP photos. The glasses are powered by two 150 mAh lithium batteries that provide a combined runtime of 6 to 8 hours on a single charge. The Lawk 1 Arkansas glasses are currently the subject of a Kickstarter campaign, with a pledge of US $349 getting you a set. The planned retail price is $499. Humanitaria's invention is a low-cost cardboard bed designed to improve humanitarian aid response. Traditional refugee camp beds cost $110,000 to $220,000 for 1,000 beds, taking 2 weeks to produce and ship, while humanitaria beds cost $17,000, are produced quickly in major cities, and can be set up in 20 minutes. The bed can support 350 kilograms of weight, and offers an 80 to 90% reduction in purchase price, making it more efficient and cost-effective. Humanitaria's solution reduces the time it takes to set up field hospitals during humanitarian emergencies. Cardboard, the primary material of the bed, is cost-effective and durable, providing shelter during emergencies. Humanitaria aims to democratize humanitarian aid by making it accessible to both large and small organizations. The bed is designed for immediate response to peak demands, thanks to existing packaging industry automation. The Super Sub is the world's fastest private submersible with a top speed of 10 knots, 18.5 kilometers per hour. It is designed for speed and agility, with a hydrodynamic body and hydrofoil-equipped thrusters. The Super Sub can go to a depth of 300 meters, 1,000 feet, and has an endurance of around 8 hours. It features a 2-passenger, 1-pilot bubble cabin and a variety of safety features, including an automatic maximum depth protection system and a deadman switch.